Okay. Hi everyone. This is Rajendran from Saravanan. My license number is PB25046. This is my assignment. Our assignment for engineering society for engineering society. Assignment number 2. So we'll be explaining about interesting topic of developing developing develop- to develop a decarbonization roadmap. Topic number 20 hours. So let's uncover what it's topic about so that you guys understand the importance of decarbonization roadmap. So you guys gonna learn something new, something fresh, and let's go. What is the decarbonization roadmap? It's called the strategic rules where we will help to sustain our economy and take care of our environment. So let's go on to the next slide. Okay, for the team here, I'm the group leader. The list will explain about the context setting and define the moral problem. Nick will explain about the analysts and stakeholders of facts. Where Chris explains the evidence of options for action, and Kitika will explain about the final judgment. Okay, now let me ask a very important question. How do we save the planet without destroying the economy? That's a very important question. We're going to understand this question. How are we going to save our planet without destroying our economy? Next, decarbonization is a professional obligation, not just a fact. It's a professional obligation where it comes to the reality, the engineering role, and the constitution. Where we have to reduce our carbon dioxide so that we can reduce the amount of pollution happening in our environment. And what as we engineers, what's our role is we have to make sure to design a new style of power plants, a new style of manufacturing lines, a new style of transportation grid, where we are the architects for the future. We are going to create something whole new. And we need to understand this is not a theoretical exercise. It involves real world infrastructures which relies on daily necessities. So, the central conflict here, sustainability and reliability. For global demand, every government in the world are focused on sustainability. But then we have seen the social demand. What are the community asking? They are asking for reliability and affordability. So let's understand something. Two are important, but we have to understand that how we are going to make sure we're going to solve the problem. So we can simply switch off every power plant. That will be very catastrophic. We have hospitals power and doing prices of quota and increase of employment. This is very dangerous. We have to avoid it at all costs. Let's discuss now. We want to discuss the methodology. Where is the test of roadmap coming from? So the ethical cycle framework, where we begin with the moral problem statement. Then we go to the problem analysis, options for action, ethical judgment, reflection. First, framework by Ben, therefore, Los Angeles propose that to eliminate feeling or intuition from the decision making process is to destroy the goal of feeling or intuition. When it comes to decision making, we need data, we need analysis, we need calculation to make the right decision. So compliance to ensure that we are asked the final roadmap that adheres to our BM, Board of Engineers Malaysia, and our Code of Ethics and SCPE. We have two values here to see here. Value number one, public welfare, and value number two is public safety. But we have to focus on the economic stability and the environmental protection. Both are important, but if one goes higher, the one goes down. Same goes vice versa. If we focus on economic stability, we will ruin the environment. But if we protect the environment, our economy will go down. I'll give you another example later on. But let's see the public welfare. Where the public need employment, cost of living, and access. These three important things are very important for any human working, staying anywhere in the world. Where we have to protect the jobs, we have to maintain the sustainable amount of energy, and we give them free access without paying so much to us. Meaning that a minimum spend of money. Cost of living is getting higher, employment is getting lower, access is getting lower. So we need to find a solution. So implication, this drives the business to inertia, where it means that business that have seek more reliable sources. So we have to see in those kind of terms. And before that, you must check public safety, especially the environment. We need to prevent pollution from happening even further. So from this roadmap, we have to stop the image of carbon dioxide happening around our atmosphere, where it will happen and prevent most important disaster, floods, droughts, and heavy rain. This can be have to prevent as soon as possible. And it's because in the end, it's for our long-term survival, as ensuring the planet remains habitable for us and for our children and grandchildren and so on, for future generations. Implication that must be understood, these values drive and radical changes. The ethical products in the code. Engineers shall hold paramount the safety of health and welfare of the public and species of active environmental protection and sustainability. Very important in this code. We engineers must understand safety, health, and welfare of is not a negotiable issue, not negotiable at all. Then it's capping the by nature, but by nature is as usual. When they go so, this can affect the further prioritize of economic and environmental destruction. It prioritizes environment, but it causes economic risk. For radical show up and go hand to hand together, where we can understand take away either Exchange is either exchange is an acceptor or outcome of exchanges. So the objective, uh, just transaction, meaning that from fossil fuel to the just transition takes time, takes effort. So we need to have good engineers, have good planning, good resources, good materials, so that we can come to this a good economy of fully good energy. So transition to a renewable energy source is possible enough to protect our humanity and provide enabling economy sustainable for the community. So we have to come together as one unity, one people to make sure we have a bright future in hand. So to grasp the problem statement, how can engineers formulate and this is our problem statement, how can engineers formulate a decarbonization roadmap that translates to renewable energy effective enough to mitigate change, balance simulation, protect the economic stability and social welfare, the economy. So I'll pass the next slide to Nick. Nick will take over. Thank you so much for watching my part. I hope you guys learned something new. Bye bye and see you slide soon. Thank you so much.
Assalamualaikum and good evening. My name is Mohd bin Rosli. My matrix number is TB25040 and I'm going to talk about the problem analysis and options for action. So for problem analysis, there are 6 stakeholders. Firstly, engineers and technical professionals. They are responsible for designing, implementing and maintaining low carbon technologies while ensuring safety, reliability and ethical compliance. Second is the government and policymakers. They formulate regulations, incentives and policies that guide national decarbonization efforts and ensure compliance with international climate commitment. Third is the industries and businesses. They are the major contributor to carbon emissions who must balance environmental responsibility with operational costs, competitiveness and profitability. Fourth is the local communities. They are affected by environmental quality, job opportunities, energy prices and infrastructure changes resulting from decarbonization initiatives. Fifth is the future generation. They will experience the long-term impacts of today's decision, including the climate stability, resource availability, and environmental sustainability. And lastly is the environmental and ecosystem. They impacted by carbon emissions through climate change, biodiversity losses, and ecosystem. For additional information, the carbon emission from industrial activities, energies, and production are a major contributor to global climate change. The renewable energies technologies like solar, wind, or the energy storage are technically available, but proven high initial capital investment. And then the carbon incentive energy systems threaten long-term societal welfare and economic resilience. The key ethical tensions is that the safety versus the speed. Rapid decarbonization may introduce technical and operational risks if systems are not fully validated. And then economic welfare versus environmental protection. The short-term economic impact is versus the long-term climate benefits. And then lastly is the present needs versus the future right. The current energy demands versus ethical responsibility to future generations' goals. And then for the option for action, for the first option, we have manage and phase decarbonization safety first transition. For the safety and welfare consideration, they maintain energy reliability and grid stability. And then they allow time for risk assessment, testing and safety validation. It protects employment through retraining and just transition programs. They minimize disruption to communities and critical infrastructure. And for the ethical strengths, it balances climate responsibility with the duty of care and reduces risk of unintended harm during transition. And also it aligns with precautionary and responsible engineering practice. However, the limitations is that it will become slower progress toward the net zero targets. And also it requires strong governments to prevent delays or complacency. And then the second option, which is the accelerated net zero transition with safeguards. For the safety and welfare consideration, it reduces long-term climate-related risks to public safety. It requires intensive and management redundancy and monitoring. And then the short-term economic and social pressure may affect vulnerable groups. For the ethical strengths, it will give the strong commitment to climate protection and intergenerational justice. It demonstrates the leadership in addressing global environmental risks and prioritize long-term public welfare over short-term convenience. However, the limitations is that the higher immediate safety, operational and economic risks. and the potential public resilience if welfare impacts are not well managed. And lastly, the third option, which is minimal transition with risk acceptance or business as usual. For the safety and welfare considerations, it avoids immediate system changes. It exposes society to increasing climate-related hazards and transfers risk and burden to the future generation. For the ethical weaknesses, it fails to address non-environmental and safety risks. It undermines long-term public welfare and sustainability, and it contradicts responsible risk management principles. For the limitations, it will have high long-term environmental, social, and economic costs, and it is ethically difficult to justify given available knowledge and solutions. So that's all for me, and thank you for listening.
Okay, my name is Muzakir bin Muhammad Rifaiee, the ID number TG25006. Okay, now we start to step 4, ethical judgment. Okay, first, Professional Code of Ethics, BM Code, Regulation 24. Registered person must hold paramount the safety, health, and interest of the public while reducing adverse effort on the environment. So, in SPE, Code Canon 1, the engineer should hold paramount the safety, health, and welfare of the public. And then ECUK statement, Principle 2, duty to protect and improve the quality of built and natural environment for current and succeeding generations. Okay, next we see the ethical evaluation of decarbonisation option. Okay, I give a 3 option for the option A, B, and C. Okay, the first one we see business as usual. Okay, the main idea is go slow, keep using fossil fuels, avoid big change. For the ethic checks, fail, put economy first, ignores climate danger, violated hold paramount safety of public. Okay, the result unethical. Okay, but we see the option of B, aggressive, rapid shift. Stop fossil now, switch to 100% renewable very fast. Okay, the risk good for environment but may crash economy and cause blackout. The result is unacceptable for me. Okay, the option C is gradual and just transition. Based in renewable, use some gas temporary, support worker and communities. Okay, the ethic check is pass, balance, climate safety, pass economy stability mesh. And the result I give the most ethical. Okay, we see the key ethical principle and global content. Harness and integrity. For option C, allow for transparent communication of trade-off and realistic timelines. Okay, next, the sustainable development. Protect the environment for future generation without sacrificing present stability for an SPE. Okay, the next, social responsibility. Address equity by providing safety net for vulnerable communities and fossil fuel workers. Okay, see the legal element. First, Paris Agreement. Malaysia 50% carbon reduce target by 2030 and ETR target 70% renewable energy by 2050 through just transition. Environment Quality Act 1974 regulation emission. Okay, now I explain about the justification for option C. Why option C is my morally accepted option? Okay, first, absolute paramount. It is the only option that simultaneous safety, public interest, and environment reduce for BM24. Second, based on realistic assessment of grid stability and technological reduce better than regular or over optims. Okay, the 3, protects workers and local communities, ensuring a social license to operate. Okay, lastly, for conclusion, I give option C if the only choice that fulfill all principles of professional engineers ethics. Summary of impact 1, protect public safety and health, reduce environment impact, ensure integrated national equity. Okay, by the final statement, as engineers, we are obligated to recommend option C as the practical, ethical, and inclusive path forward. Okay, that's all.
So for my part on reflection, I would like to explain limitations of the ethical framework. So based on our topic, economic mortality, this is the first point. Our roadmap, which we choose the decarbonisation roadmap. The roadmap relies on current market stability. So unforeseen global economic shifts could disrupt the transition. And the second point is technological uncertainty. Success depends on the timely scaling of innovations like green hydrogen or carbon capture. Delays could alter the ethical balance. So this is what we have surveyed on reflection of our topic. And then we have intuitive judgment, and there's 2 points under it. The first one is the fairness principle. A gradual and planned approach feels intuitively right because it avoids the mass poverty risk of a radical shock. And the second point is intergenerational balance. This path satisfies our moral intuition to protect both the current workforce and the safety of future generations. Then when we see the conclusion, the morally acceptable action. So our final verdict is that implement a gradual and planned decarbonization program. So if you're wondering why we should take this action, why this certain action, it is because there's three main points. The first one, it protects public welfare. As you know, it is the only option that passes the ethical test by balancing immediate safety with long-term health. The second point is phased innovation. It allows for the integration of renewables while maintaining social safety nets and grid stability. And the third point is the engineer's mandate, where engineers must act responsibly by balancing innovation sustainability and societal impact. So the decisions must prioritize the just transition to ensure no community is left behind. So the third one is references and compliance. As we know, we must clearly quote our BEM and everything. So here are the list of the professional codes of conduct, which is BEM, focuses on the engineer's duty to prioritize public interest and sustainable development. NSPE Code of Ethics hold paramount the safety, health, and welfare of the public, which is the core principle of validating our roadmap. Third is Engineering Council UK, which emphasizes high standards of environmental stewardship and ethical leadership. And the fourth is Global Context, where our roadmap aligns with current government policies and international climate reports. Thank you.